Section 6.7 is about polygons in the coordinate plane. You will be identifying what kind of a triangle or what kind of quadrilateral you have created after you've plotted some points. You may need to use some of these formulas. You will probably end up using the distance formula at some point, and you may or may not need to use the slope formula depending on what is your preference. So you might keep those at hand in case you need them for later on. So let's look at an example. This first one asks if this triangle is scalene, isosceles, or equilateral. First, you need to know what those definitions are. So remember, scalene means I have 0 sides equal to each other. Isosceles means I have 2 sides equal. And equilateral means that all 3 sides are equal to each other. So what we're going to do is, we're going to need to find the lengths of each side in order to determine if I have any sides with the same length or equal to each other. So what you're going to do is, since none of these are horizontal or vertical lines, which means I could just end up counting on my grid, I will have to use the distance formula. So I first wrote down the coordinates of each point, and A is at 0, 1, B is at 4, 4, and C is at 7, 0. The next step is I want to find the length of each line. So I'm finding the length of line AC. So therefore I need to use point A and point C and plug it into my distance formula up here at the top in order to find what that length would be. So the distance formula says subtract your x's, which I did, subtract your y's, and then square it and find that sum, and then do the square root of that. So I found the length of AC to be 7.1. Then I went to the next line. So the next one I did was BC. So I used points B and C. From that, I did the distance formula again. Subtract the x's, subtract the y's, squared those differences, added it, and found the square root. And I found the length of BC to be 5. Last, I did the last line, which was from A to B, used the distance formula, and found that AB was also 5. So notice that both of these lines have the same length. So therefore, if I have 2 sides equal to each other, I have an isosceles triangle. So my answer is isosceles. So you're going to pause the video and you're going to try the next question and determine what kind of triangle you have. So on the next question, you had to plot those points if you wanted a visual. Then you needed to find the distance to determine the lengths of each side. When I found the distance from DE, I found 4.1. The length of EF I found was 4.5. And the length of DF I found was 5.4. Since none of those sides have the same length, this would be a scalene triangle because none of the sides are equal. Okay. Now you're going to work on quadrilaterals. So quadrilaterals are a little bit different. So you may want to jot down this little figure that I have here. The first thing we're going to check is if I have 4 congruent sides. And if I do have 4 congruent sides, then I'm going to check if I have 4 right angles. If my answer is no right angles, then it's a rhombus. If I do have 4 right angles, it's a square. Then I'm going to come over here. If I don't have 4 congruent sides, I'm going to check for 4 right angles again. If I don't have 4 right angles, it's a parallelogram. If I do, it's a rectangle. Okay, let's take a look here. So on this first one, I plotted the points, and this was the shape it gave me. Now some people are able to just kind of eye it, which I would strongly encourage you to not just look at the picture, but actually be able to justify your answer. So remember, the first thing I'm going to do is I'm going to check if I have 4 congruent sides. So I need to find the distance. Now, if these are horizontal or vertical lines, I can just count along those boxes. So use that to your advantage if you get any of those. These are not horizontal or vertical lines, so I'm going to have to do the distance formula for all 4 sides to see. So I went ahead and did that. I did AB, which I found was the square root of 20. I did BC, which was the square root of 17. These sides are not congruent. So if those sides are not congruent, then their opposite sides are not going to be congruent, showing that the 4 sides aren't congruent. So if you pick one side and then another side right next to it and they're not congruent, you can just stop there and go on to the next step. So since those are not congruent, now I'm going to check for 4 right angles. To do that, you need to find the slopes of your line. Now some people prefer to use the slope formula. So if you were going to use the slope formula, you would want to use the points A and B and find the slope of that line. And do the same thing for B and C. Now, you can use the slope like I showed you here, or a faster way is just count your rise and your run. So if I was going to go back up here to the graph, I would start at letter A and count my rise, which would be 1, 2, 3, 4. Count my run, which would be 2. So 4 over 2 shows that my slope for this line is 2. Then I would do the same thing for BC. Count my slope or my rise and my run. So I would go up 1 and over 2, 3, 4. So the slope of BC is 1/4. Notice you get the same thing that you do with your slope formula, but it is a faster method to just count the rise and the run. So it is your preference which way you want to do it. Now go back to the big idea. How do I know if they're right angles? Well, right angle means that it's perpendicular. If I have slopes that are perpendicular, they have to be opposites and reciprocals of each other. These are not even the same number, so no way can they be opposite of reciprocals of each other. So this is showing you that these lines are not perpendicular to each other, which means there's not right angles. So therefore, I answered no to congruent sides, no to right angles, so therefore my answer has to be a parallelogram. Now this goes back to the fact of knowing what each shape is. And so remember, a parallelogram has no sides, or I don't have 4 equal sides, and I don't have 4 equal angles. Okay? Alright, I want you to pause the video and I want you to try the next one. So on the next one you had this shape. So right off the bat it either looks like a rhombus or it may be a square. So the first thing I would check is, do I have 4 congruent sides? When I found the distance of every single one, they ended up being all the same. So yes, I have 4 congruent sides. So it is a rhombus or it's a square. Now I need to check if my lines are perpendicular. So here is where you're going to just pick 2 and find their slopes. So either use the slope formula or come up here and do your rise over your run. So if I did rise over run, I would go down 1, 2, 3 over 1. So the slope of NM would be -3 or -3 over 1. Then I checked NP, so I would go up 1 over 1, 2, 3. These two slopes are opposite reciprocals of each other. So since they are opposite reciprocals of each other, those have to be perpendicular. And if you wanted to, you could go ahead and check the other set to make sure, but more than likely those are going to be opposite reciprocals as well. So therefore, going back to my little figure, I answered yes to 4 congruent sides, I answered yes to 4 right angles, so therefore my answer is a square. So notice again, you can go off of what the picture looks like, but you need to make sure you can justify it. So yes, it looked either like a rhombus or a square, but I had to determine that by showing my slopes to see if they were perpendicular.